Okay, let's start from probability checkup questions. First part is based on experimental probability. Here they have given a table which records how long Raika's new laptop battery lasted each day. So in this table it shows time in hours, then there's the frequency, and there's another column you have to fill with the experimental probability, right? So they are telling you to copy and complete the table, and then before we go for the next parts, we know usually what we have to do. So what we have to do first is to calculate the total frequency, right? Okay, have you all calculated it?
Yes.
Okay, what's the total frequency? 40. Okay, I'll just type it. We got the total 40, right? What about the experimental probability for 7 hours?
5 upon 40.
5 upon 40.
9 upon 40.
9 upon 40.
16 upon 40.
Yes, 16 upon 40. So each frequency we have to write
7 upon
over the total frequency. So next one is 7 upon 40.
3 upon 40.
3 upon 40, and that's all, right? So now in part B it says that she has said the battery is unlikely to last more than 8 hours in a day. Unlikely to last more than 8 hours a day. Unlikely means almost like 25%, right? So then they are telling you to find two questions here. Estimate the probability that her battery will last more than 8 hours tomorrow.
65%.
Okay, how do you do the calculation?
Divide 26 by 40.
Right, let's see how many times, what is the frequency where the battery has lasted more than 8 hours. So when they say more than 8 hours, can we take 8 hours? No, we can't take 8 hours. We have to take 9, 10, 11 hours. So when you add all these three frequencies, you get the value there. How much is the value?
26.
26. So you can say 26 upon 40. 40 is the total. So what is the percentage value in that?
65%.
It's 65%. Is that clear? So based on the percentage we got, above 65 is? Above 65 means it's like even chance, no?
Yes.
Because it's closer to 50%. So if it's less than, if it's 25% or less than 25%, we can say it's unlikely. And then they're asking in the second part, based on the data, is she correct?
No,
Is she correct?
she is wrong.
No, she's wrong because it shows even chance. Okay? Right. Next one. Okay, I'll type the answer. No. The percentage shows it is even chance. Okay. Part C. Are the experimental probabilities a good model for predicting how long Raika's battery will last? The day after the experiment finished. The day after the experiment is finished, is it good to use this data to find the values?
Yes.
Yes. The reason?
The data is recent.
The data is recent. What about 6 months later?
No. As the data is older, the battery efficiency will be less.
Data is older and the efficiency of the battery
Will be
less. So the explanations are given there. Let's move on to question 2. The chart shows how a plantation's bananas were used. How many bananas were grown altogether?
500,000 bananas.
So what you have to do is, now what type of a chart is this?
Bar chart.
Bar chart. So they have given you the frequency of each how each banana is used. So some were in the supermarket, some were dried, some were processed, and some were used as animal feed. What you have to do is add them all together and find the answer. So what is the answer?
500,000 bananas.
So writing 500,000 is enough. Right. Estimate the probability that a banana will go to the supermarket.
50%.
So now what is this one? This is a total frequency like we used in these tables, right? What you have to find is the probability that a banana will go to the supermarket. So what is the frequency of the supermarket? 250,000 divided by 500,000. What was the answer then?
50%.
Yes, this equals to, we can write the answer here, no? This equals to 50%. Is that clear?
Yes.
Right, then the second one, it says will be dried or processed. Dried or processed means you can take both, right? So how many dried? 50,000. How many processed? 150,000. So you add them both together. How much you get? 200,000 divided by the total frequency. Total frequency is 500,000.
40%.
So what will be the percentage? When you do the calculation, you will get 40%. Have you got the answers?
Yes.
Huh? Okay. Right. Question 3. A quality control inspection of 200 watches found out that 20 were faulty. Estimate the probability that a watch will be faulty. So how do you find it? How many were faulty? 20. How many altogether he inspected? 200. So what will be the answer?
1 upon 10.
1 upon 10 will be the answer. 1 upon 10. Clear?
Yes.
Did you get the answers?
Yes.
Okay. Right, let's move on to the next one. Right, now the second part is about estimating probability. So question 4 onwards you get this type of questions. Let's see what it says now. The table shows information about the number of orders for new cars received by a car dealership during certain months. So number of the months are given there, and then in the second row it shows the number of sales made each month, right? An order is chosen at random. Work out the probability that the order was received in July, then September or October, not June. So how do you do this? Let's find the total frequency here.
160.
What is the total frequency you got?
160.
160. Okay, let's add it up and see then. 25 plus 36 plus 30 plus 28 plus 29 plus 12. 160. You have to check your simple calculations. Right, what is the answer you got for July?
30 upon 16. When we simplify, it's 3 upon 16.
30 upon 160 is the answer. When you simplify, you can get 3 upon 16. So you can just leave the answer as a fraction. And this is for July. What about September or October? That means what do you have to do? You have to add September and October both. So 29 plus 12 is 41 upon
160.
160. Can you simplify it further?
No.
No. Then not June. Not June means without June you have to take all the other ones. So how much is that?
124 divided upon 160. When we simplify, it's
124 divided by 160. You can simplify it further.
31 upon 40.
31 upon 40. So these are the answers there. Did you get them? Ah, yes. Okay, you can correct it then. Okay, let's move on to question 5. The table shows the visitors to a park on a Sunday. Work out the relative frequencies for adult, girl and boy. Okay, so what do you have to do when you see this type of a table? First thing you have to do is to find the total frequency. What is the total frequency here? 200. Right, now they are asking us to calculate the relative frequency. For adult it's going to be 70 upon 200.
90 upon 200 and 40 upon 200.
Yeah, 90 upon 200 and
40 upon 200.
40 upon 200. We can simplify this further, but let's just keep it that way for now. Right, okay, so first part is done. Second, they're saying estimate the probability that the next visitor is a girl. Write your answer as a decimal. What is the answer you got?
I got it as 0.405.
Right, so what is the value we are going to put here? 0.45?
We can take 0.4 round up.
90 divided by 200, 0.45. So when you write it as a decimal, you can write it. Why?
0.405.
45. Okay.
Yes.
Right. Then they are telling you that the park has 300 visitors one Sunday. How many boys would you expect? Now what we know here is out of 200, if 200 people visit the park on a Sunday, we know this much of boys will be there. Using this, you have to find if 300 visitors visit the park on Sunday, how many boys you are expecting to see there. How do you do it? You have to get the relative frequency of the boys here. That is 40 divided by 200, and then you have to multiply it by 300
equals 60.
Equals how much?
60.
How much you got?
60.
60. Is it clear?
Yes.
Right. Next question. A computer repair company keeps records of all the repairs it makes to laptops. The table shows information about all the repairs made in 2018. The cost is given in pounds here and the frequencies are given here. Amina needs to repair her laptop. Estimate the probability that the repair will cost more than 300. More than 300, what are the values you are going to take? And first let's calculate the total frequency here.
It's 120. Yeah.
120. Okay. 120. Right, this is the total.
Yeah.
Right. Now more than 300, when they say more than 300, which values are we going to take?
22 and 5.
Yes. It should be more than 300. So 300 is not allowed.
Yes.
Right. So more than 300 you can go with the last two, 22 and 5. So there how much you are getting? 27 upon
120. When we
Okay.
simplify, it's 9 upon 40.
9 upon
40.
40. Did you get the answer? Huh?
I wrote it.
You wrote it just now. You didn't do it.
No, I didn't know that minus 140. I only did
27. Right, okay. So anyway, try to simplify the fractions and keep them. That's the best way to write. Okay, between 100 and 300. 100 and 300. What are the values we are going to take then?
38 and 30.
Yes, we are going to take the second one and the third one here. Right? Between 100 and 300. So it's 38 plus 30. 38 plus 30. It's going to be 68 divided by 120. Can we simplify it further?
Yes, 17 upon 30.
17
Upon 30.
upon 30. Did you get these answers?
Yes.
Comment on the accuracy of your estimate. Have you written any comment there?
No.
Right, so you can write down the answer like this. The estimate is based on the data in the table. Sorry, estimate is accurate based on the data in the table. Right? Okay, next there's a challenge question. I told use a calculator and see if you can find the answer. Anyone who
I only did the table.
only did the table. Okay, shall we see if we can see if we can do it? Let's do it together then. A box contains milk chocolates and dark chocolates. There are 200 chocolates in the box. Onik takes a chocolate at random from the box, record its type, and then replaces the chocolate. Copy and complete the table of relative frequencies for the number of times a milk chocolate was chosen. Okay, so altogether how many are there? 200 chocolates altogether, 200 chocolates, right? He takes one at random and then he records the type and replaces it back. And then they're asking you to copy this table, copy and complete the relative frequencies for the number of times a milk chocolate was chosen, right? Number of trials are given here. So how many times he did it and how many milk chocolates were chosen each time, right? Can you complete the table?
Yes, I completed.
Okay, so what you have to do here is 4 upon 10. You have to take for this particular one. Don't calculate the whole thing, okay?
Yes.
Because each time he has done for a certain number of trials. So you have to take that trial number as the total frequency for each one. Right, for this one it's going to be 8 upon 25. So what is the value?
0.22.
It's going to be 8 upon 25, which is 0.32. Right. Next one it's going to be
0.28.
no. What are the values we are going to write? 14 upon
50.
right. What's the value here?
0.28.
0.28. And here it's 30 upon 100, which is 0.3. Yes, you can just ignore the 0 at the end. You don't need to write it. So we can take it as 0.3. Right. What is the best estimate for the relative frequency of picking a milk chocolate from the box? Now there are so many times he has done this experiment or this testing, right? So each instance, now first one he has taken 10, second one it's 25, third time 50, and last time he has taken 100. So which one do you think has the best estimate of the relative frequency?
0.4.
Why 0.4? Which one you are telling?
0.4.
Wrong.
It will be 0.
Do you remember we told if we are doing an experiment like this, we have to take the one with the highest number of trials because that tends to give the best estimate. Okay, the more you perform a test, the more confident you are with the data. Do you remember we did it yesterday also?
Yes.
If you can't remember, you can check the recording or you can go through your book. There is a key point also, right? So we are going to take which number?
0.0.
Okay, so they are asking what is the best estimate of the relative frequency. So you can't just say anything else. You have to write it with 0.3. This is what we are going to use. That means 30 upon 100. So you can write the answer 30 upon 100, which is equal to 0.3. Now we know in this box we have there are 200 chocolates, right? What is the best estimate of the number of milk chocolates in the box? Now this is for 100. No? Now if we use this best estimate of relative frequency to find for the entire 200 chocolates, what will be the answer? It's going to be 30 divided by 100 multiplied by 200. What is going to be the answer then? Answer is going to be 60. So out of all the 200 chocolates, we can estimate that number of milk chocolates will be 60. Is it clear?
Yes.
Okay. Copy down the answers if you are not done now. Alright, let's move on to the strengthened questions. Experimental probability. Have you all done these questions?
Yes.
Huh?
Yes.
Okay. Sanchez's teacher secretly put 10 cubes in a bag. Some were blue, some were yellow, and some black. Sanchez took one out and recorded its color in the tally chart below. Then he put the cube back into the bag. He repeated this 20 times, right? Complete the frequency column. Now you have to count the tally marks and write the values. What are the values you got? For yellow, it's 5 and 2 for black. Right. Total is 20. Right. Now complete the, okay, now we did the total frequency calculation. Now they are asking to write the experimental probability of picking each color. Right, for this one it's going to be 5 upon 20, and then here it's going to be 2 upon 20. Is that clear?
Yes.
Right. Okay, so we did A, B, C now. Which counter is more likely to be picked from the bag? Black or yellow? Is it black or yellow? Huh? Which one has the highest experimental probability from these two, black and yellow? Yellow. So you can write the answer as yellow. Did you get it?
Yes.
No?
Yes.
Okay. Right, so here you can write the answer as a fraction. You can simplify it and write. You can write it as a decimal or you can write it as a percentage. Doesn't matter. Okay, then next one. The tally, question 2. The tally chart shows the visits to some post office cashier desks on a Saturday morning. Cashier desk 1, 2, 3, 4, 5. The tally mark shows the frequencies for each desk. So you have to obviously calculate the total frequency and the estimated probabilities here. Have you all done this?
Yes.
Yes, let's go with the answers. It's 16. Next one is 25, 30, 15. What's the total? 100. Okay, so how do we do this? 16 divided by 100 equals to 16%, and here 25 upon 100 equals to 25%, and here 30 upon 100 equals to 30%. 15. Okay, is it clear how to take it? So copy the table and complete the frequency column. Which cashier desk was visited by most of the customers? So which one was visited by most of the customers?
Cashier desk
4. Cashier desk 4, right? Okay, and then they're asking you, work out the estimated probability that the next customer will visit cashier desk 3.
50%.
Cashier desk 3.
25%.
What is the value of cashier desk 3?
25%.
25%, and they are asking you to write your answer as a decimal. How do you write it then?
0.25.
0.25. Oh, sorry, not as a decimal, percentage. So it's 25%. Alright? Okay, next part C. The post office manager says that the probability of a customer visiting cashier desk 1 next Monday is 14%. Right? Now look at desk 1, it's 14%. Right? This is based on Saturday's details. Right? And they are asking, the post office manager has said that probability of a customer visiting cashier desk 1 next Monday is 14%. Explain why this might not be true.
Because he has given percentage which has been on Saturday.
Yes, there's a question Q2C hint. See? Think of a reason why things might be different in the post office on Monday compared with on Saturday. So Monday and Saturday are 2 different days. Saturday is the beginning of the weekend, and then Monday is the beginning of the working days, weekdays. Think of a reason and tell me. I'll give 30 seconds. Yes, anyone who has a reason?
Because there could be more or less customers the next day.
Yes. Any idea? Okay, so you can just simply write the number of people visiting the post office next Monday may be different to Saturday. So similar to your answer. So it can be more or less. So taking the data on a Saturday and predicting about a Monday is not really correct. Right, let's move on to question 3. It's a real STEM question. The bar chart shows the wildlife spotted on a Scottish boat trip in July. Again, what type of a chart do we have here? It's a bar chart with the title Wildlife Seen in July. Then there's a frequency given here and the type of animal they have spotted. How many animals were spotted altogether? What are they asking you to do? The total frequency there. So what is the total frequency? 10 plus 20 plus 5 plus 15. So answer is 50. Altogether they have spotted 50 animals. Estimate the probability that the next animal spotted will be a basking shark. So what is the probability? Shall we write it like this? P within brackets basking shark equals, okay, how many times they have witnessed a basking shark? 5 times. Out of total number of animals they saw was 50. So what is the answer? 1 upon 10. Did you all get it?
Yeah.
Huh?
Yes.
Right. Okay, then question 3 part C. Is your answer a good estimate for spotting a basking shark on a boat trip in January? Give a reason for your answer. Now they are considering the details they have, data they have captured in month of July. And when are they going to now estimate what for which month they are going to estimate it? For January. So how many months after? Almost like 6 months after, right? So then there's a hint given here. Think about the temperature of the water at different times of year. So you know it's Scottish boat trip. So those countries are not like our country. So we have summer throughout the year, but in European side they have winter season as well. So January mostly it's a very cold weather there. So do you think the animals who are coming out in summertime will be visible during the winter time?
No.
No. So tell me a good answer. Have you all written any reasoning for that? Okay, so considering the timing, you can write the answer like this. It's not really a good estimate, because the number of basking sharks seen in the winter may be different from the number seen in the summer. This is 3 part C. Okay, right. Okay, so for question 4, copy the table shown below. Roll a dice 60 times and record your results in the table. Work out the probability of rolling each number. So the numbers you get here are given in the first column. It's from 1 to 6. So when you have to do it on your own and find your own answer. So there is no right or wrong answer here, as long as you do it the exact way. So you have to roll the dice 60 times and record the answers. How many times you got? 1. When you roll 60 times, how many times you got? 1. How many times you got? 2. 3, 4, 5, 6, like that. You have to write it in tally mark. So what is tally mark? You have to just write it like this. Now for example, let's say I got 5 times, right? Then what is the frequency? 5. And how do I write the probability? 5 upon 60. Similarly you have to do for the other numbers, and then calculate the total and write it here. So when you take the total, it will show. Now altogether you are doing 60 times, so you are going to get a probability of 60, which is equal to 1. Okay, that is about that question. So that is something you can do on your own and write down the answers. Right, next is about estimating probability. Question 1. A potter made 100 plates and 10 of them cracked. Estimate the probability that the next plate the potter makes cracks. How do you find it? How do you do it?
Is it
10
10 upon 100?
upon 100. Then for B, it says the potter makes 200 plates. How many would you expect to crack? So for 10, if it so for 100, if it's 10 plates, for 200, how do we find it? 10 upon 100 multiplied by 200. What is the answer?
20%.
20 plates, not percent, 20 plates. Is that clear?
Yes.
Right. Let's go to question 2. Anton's aquarium has 3 types of fish: catfish, rainbow fish and sunfish. Nice names. Okay. So he recorded the first 20 fish to swim to the surface. Now for the catfish, he had a frequency of 6. So relative frequency is 6 upon 20 because it's altogether 20 fish to swim to the surface, right? Then for rainbow fish it's 10. So it should be 10 here. Here should be 10 upon 20. Sunfish it's 4. Then it should be 4 upon 20. Estimate the probability that the next fish to swim to the surface is a catfish. What is the probability of the next fish coming as a catfish? 6 upon 20. So what is you can write it as a percentage also. What will be the percentage?
Is it 30%?
It's going to be 30%. Very good. So you can modify this answer a little bit as P catfish. Probability of getting a catfish is 6 upon 20. We can write it as 30%. Is it clear? Right, next one, estimate the probabilities for rainbow fish and sunfish. Rainbow fish how many? 10. Sunfish is 4. So it's
14 upon 20.
yes, so you can write it so for this one you can write them separate. You can write this probability separate. So let's write P. Which one we are going to write? The rainbow fish. Rainbow fish is how much? 10 upon 20. What's the answer?
The answer is
50%. And the probability of sunfish is equal to 4 upon 20, which is 20%. So don't mix up and write them together as a total. Just write the answer as in separate ways, separate probabilities. Then next one, Anton records the next 60 fish to swim to the surface. How many would you expect to be catfish? Right, so for part C, 1. For catfish, what is it going to be?
Is it 6 upon 20 times 60?
6 upon 20 times 60. What's the answer? 18. Right, next for the rainbow fish is 10 upon 20 multiplied by 60, which is 30. Have you got it? Then the third one is for the sunfish. Sunfish is 4 upon 20 multiplied by 60. Answer is 12. Is that clear? Okay. Let's go to the next one then. Right, for question 3. In the last 2 months, Dev has taken part in the 3 sports shown in the table. So he has gone for swimming, cricket and judo, and the number of frequencies are given there. Estimate the probability that the next sport Dev plays is cricket. So before we move on to that, let's calculate the total frequency here. What is the total frequency? 40. Total frequency is 40. You add all 3 together, you get the total frequency here. Right, estimate the probability that the next sport Dev plays is cricket. How many times has he played cricket? 8 upon 40. So you have to write the answer there. What is the answer you got? You can simplify and write it as 1 upon 5. How many times Dev take part in judo or swimming out of the next 50 times he participates in sport? So now he is saying he is going to participate 50 times. Now this data is based on 40 times. So they are asking you to find how many times for judo or swimming. So you have to take both. 12 plus 20, because for swimming it's going to be 12, judo it's going to be 20. So you're going to add these two, which is 32 upon 40 multiplied by how many times? 50 times. 50 times, right? So what is the answer? Yes? Answer is 40. You can write the answer as 40. Okay, that's it about question 3. Then question 4. Christina Marie writes each letter of her name on a card. She shuffles the cards and selects one at random. She records the letter and replaces the card. She does this 100 times. How many times would you expect her to select the letter I? How many I's are there in this name? 1, 2, 3. 3 upon how many letters altogether? 1, no. Count in this name. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 upon 13. Right? Now, she does this. This is for the for each time she has taken, she has done it. 3 I's will come. Right? So each letter of her name, so she has written each letter of her name in a card. She shuffles the cards and select one at random. So altogether she has 13 cards here. Right? One card for each letter of her name. Then out of that, she is having 3 letter I's. Okay. Now if she does it 100 times, how many times will she get letter I? How do you do it? Multiply the relative frequency of getting a letter I for 100 times. Okay. So then what is the answer she is going to get? divided by 13 multiplied by 100. So 23 times. So you can write the answer 23 times. Okay, question 5. An ordinary 6-sided dice is rolled 250 times. How many times would you expect to get a prime number? Okay, so there's a combination of another lesson here. What are the prime numbers in a dice? Let me tell this one, explain it like this. Okay, so what are the outcomes of a dice? 1, 2, 3, 4, 5, 6. Out of these, what are the prime numbers? Who can tell me?
2, 3,
Prime
5.
number is divisible only by 1 and the number itself, right? What are the prime numbers here? 2, 3,
and 5.
5. These are the prime numbers. Okay, right. Now, how many prime numbers are there?
3.
3 out of 6. And now you are going to roll this 250 times. If you roll it for 250 times, we are going to multiply this by 250. What's going to be the answer? 125 times. Right, next enrichment questions. Have you all tried this?
No.
Reason?
It's
Huh?
confusing.
Confusing? Now I'm going to have the magical power that you all will find the answers when you do with me. Actually, why you all didn't do?
This one I read.
It's not difficult, you just have to read and understand. So another excuse to say that couldn't do the homework? Huh? No? Okay.
I read.
Alright, anyway, question 1. Find an object that has at least 2 different ways of landing when it is dropped. Sketch the possible outcomes of dropping the object. Give each a short description. I'll give a few seconds for you all to try and see now. Okay, so for the enrichment questions, these are based on whatever the experiments or whatever the things you are choosing. So you might have different answers for question 1 and for question 2. So you can try it on your own. Think of some situations and anyway try to do it as a homework then. Alright, okay, let's move on to extend questions. Anyone did question 1? Question 2?
Yes.
I've completed.
No eyes.
Huh?
Yes.
Okay. Okay, so for question 1, a bag contains €1 and £1 coins. Lee takes out a coin, looks at it and replaces it. He records its results after 25, 50, 75 and 100 trials. So for each number of trials, he has tabulated the number of €1 coins he has got, right? What is the most accurate experimental probability of picking €1 coin?
45%. 112.
45 divided by 100. So it's equal to 45%. Then in part B, Lee weighs the bag and works out that there are 40 coins in it. Now only he knows that there are 40 coins in it. How many are likely to be 1 euro coins?
80.
How do you get it? You are going to use the most accurate experimental probability, which is 45 upon 100. You multiply that by 40 coins in the back. What's going to be the answer?
180 upon 10 and
18 is the answer. Is that clear?
10. Yes.
Huh? Okay. Question 2. Maureen records the darts thrown by 2 of her favorite players. So Tom is one, Joe is another one. So they have, she has mentioned for single, double, treble, 25 ring and bull. For each one, how many times they have scored in that. Estimate the probability of each player hitting a treble. So what's the total for Tom? Total
25%?
frequency? Huh?
No, sorry, 100.
100. And for Joe?
25.
Sneaky Joe, it's 25, right? That's the total frequency. Estimate the probability of each player hitting a treble. So what's the probability of each player hitting a treble?
Tom is
For Tom, it's
25%.
how many times is hitting a treble? 25 out of 100, that is 25%. And for Joe, Sneaky Joe, it's
28%.
7 upon, sorry?
I got 28%.
7 upon 25, which is equal to 28%, is it? Yes, 28%. Okay. Alright, part B. Which player is more likely to hit a treble? Yes? Tom or Joe?
Sneaky because he has a high
Sneaky Joe, because 28% is more than 25%. Is it clear?
Yes.
Okay, so for part C, whose estimated probability is a more reliable model for their future dart throws, and explain why.
Tom.
Why?
It is based on more throws.
Tom, because the data is based on more throws than Joe. Okay?
Yes.
Right, so for part D, what's the answer? Who wrote the answers for this?
Me up.
If Sneaky Joe threw 200 darts tomorrow, estimate the number of trebles he would hit. How do you write it? Okay, for part D, if Sneaky Joe threw 200 darts tomorrow, estimate the number of trebles he would hit. So how many trebles Sneaky Joe has hit? 7 upon 25. Yes, and we are multiplying it by
20. No, sorry.
200 to find for 200. Then what's the answer?
56 times.
56 times. I hope the answers are clear.
Yes.
Okay. Right, next question. The number of FTSE 100 companies share prices that went up from the previous day were recorded for 50 days. So it's a literacy hint given here. The largest 100 companies on the London stock market are called the FTSE 100. Each day their share prices can go up, down or stay the same. It's about the share prices, right? Now in this table it shows number of share prices that went up. 1 to 20, 21 to 40, like that they have grouped it into 20s. And the frequencies for each group is given here. Estimate the probability that on the next day 21 to 40 share prices will go up. Now how many altogether? What's the total frequency here? 50. Right. 21 to 40 share. How do you write it? 21 to 40 is 12 upon 50. So were you able to simplify it further? I think 6 upon 25 only, the maximum you can go. Right, 6 upon 25. More than 60 share prices will go up. More than 60. Which ones are we taking? More than 60. Does it include 60? No. So we are going to take 61 to 80 and 81 to 100. Two groups there. Right? Altogether how much then? 13. 13 divided by 50. Okay, next one. Part B. The London Stock Exchange trades for the 357 days in a year. On how many days would you expect fewer than 21 share prices to rise? So fewer than 21 shares means you won't take 21. It's less than 21. So we are going to take the first group, 1 to 20. So it's 7. 7 upon 50 multiplied by 357. Did anybody do the calculation? Here you are allowed to use the calculator. So anyone did the calculation?
No.
Why not? So the answer is going to be 49.98, where you can round it off to 50 days. Okay? Right, so for part C, estimate the probability that fewer than 21 share prices will rise on each of 2 consecutive days. Estimate the probability that fewer than 21 share prices will rise on each of 2 consecutive days. Anyone who found the answer for that? Okay, so when they say 2 consecutive days, but it should be less than 21 share price. So less than 21 is 7, right? How do you write it? 7 upon, let me write it with the pen. So it's going to be 7 upon, how much? 50. If you are taking for 2 consecutive days, how do you write it? You have to square this whole thing. The whole thing to the power 2 for 2 consecutive days, right? So then what is the answer you are going to get? 49 upon 2500. And you will get this, when you simplify, you will get 0.0196. Right, so that's how you find the answer for that. Let's go to the next question, question 4. The frequency table shows the weights of organic Savoy cabbages grown without pesticide or artificial fertilizer. So weights are given here and for each weight group they have given the frequency. Estimate the probability that an organic Savoy cabbage weighs 1.3 kilogram or more. Okay, so tell me, estimate the probability that an organic Savoy cabbage weighs 1.3 kilograms or more. So can we include 1.3 here?
No.
Ah?
Yes.
1.3 kilograms or more. So 1.3 kilogram can be included, right? So then which groups can you take? Can you take this third one from the last?
No.
No, because it's less than 1.3. But in the last two, it says 1.3 included. Right? So here we can take the last two. So then for A, we can write the answer. 10 plus 40 is 50. What's the total frequency?
800.
800. So can you simplify it?
Yes, 1 upon 16.
1 upon 16 is the answer. So I'll just write it here. What's the total? 800. Then for B, a supermarket only buys Savoy cabbages that weigh between 0.9 and 1.3. Between 0.9 and 1.3. Which 4 you have to take? Let me show. 0.9 included now?
Yes.
Then I'm going to take from here till here. Between 0.9 and 1.3. Okay?
Yes.
A farmer produces 20,000 organic Savoy cabbages each year. How many of these can the farmer expect to sell to the supermarket? So first what we have to do is we have to take these values and add them together.
So they are equal to 580.
Yeah, I'll take the same one and do. Yes, then how much altogether when you add 130, 220, 150 and 80? What's the total?
580.
580. Did you get it?
Yes. Yes.
You got it? Why not?
I didn't do that first.
And then you have to multiply this by what?
2000.
20,000. 20,000.
Plus 14,500.
Okay, let me do the calculation and see. 800 multiplied by 20,000. What's the answer you got?
14,500.
14,500 is the answer, correct. Right? Okay, for part C, a Savoy cabbage on a market stall weighs 1,450 grams. The stall holder says it is organic. Do you believe him? Explain. Now 1,450 grams, and here what is the unit we have used? Kilograms. So 1,450 means 1.45. Where does 1.45 belongs? Here, the last group here, right? How many can he using this status? What is the relative frequency of getting 1,450 gram cabbage?
10.
Yes. So we can write it like 10 divided by 800. Right? What's the value there? 1 upon 80. 1 upon 80. Right? Uh, a Savoy cabbage on a market stall weighs 1450 grams and the stallholder says it is organic. Do you believe him? And you have to explain.
No.
Yes? So when you write the explanation, you can just do the calculation there and write the answer like this. It is unlikely to be organic. So if you simplify this further and write it as a percentage, you can get the answer as 1.25. 1.25%. So 1.25% is unlikely. It's unlikely to be organic because only 10 out of 800 weigh 1.4 kilograms of or more. Okay, done?
Yes.
Right. Let's go to question 5. How many more questions do we have to discuss? Okay, we have another 4 questions. Okay, let's do it soon then. 400 customers were randomly telephoned in a follow-up satisfaction survey. Based on previous surveys, the probability of calling someone aged 20 to 39 is 2 upon 5. A completely satisfied customer aged over 60 is 1 upon 4. A dissatisfied customer aged 40 to 59 is the same as that of calling a mostly satisfied customer aged 60 or over. Copy and complete this table using the information given above. Can you complete the table using this information given there?
Yeah, I consider.
I'll give 30 seconds to complete that. Okay, something that we can find from here is take this last one. This is easy to fill in. A dissatisfied customer aged 40 to 59 is the same as that of calling a mostly satisfied customer aged 60 or over. So dissatisfied customer age between 40 to 59, we know the answer is 12 here. It is the same as mostly satisfied customer, this column, age 60 or over. So here we know it's going to be 12. Is that clear?
Yes.
So to read this and understand which two are the same, and that's how we fill this. Okay. And then how do you do the other ones? A completely satisfied customer aged over 60 is 1 upon 4. So here they have given completely satisfied customer is customer aged over 60 is 1 upon 4. Then someone aged 20 to 39 is 2 upon 5. That is for all three of these, 2 upon 5. Now how are you going to find the answer?
What is here dissatisfied? Dissatisfied for 20 to age 20.
So 400 customers were called, no?
Yes.
So out of 400, 1/4 is completely satisfied customer aged over 60 years. So 1 upon 400 is how much? 1 upon 4 of 400 is
100.
so here we can write 100. Is it clear how we took it?
Yes.
Now here we know how much has come. How much here? 240. Right. Now here how many? 140, right? Yeah, right. Now next one, here they say 20 to 39. So it can be completely satisfied, mostly satisfied or dissatisfied. Anything, but it all together when you add them, it fills for 2/5 of this. So 2/5 of 400 is how much? Here it's going to be 80. Here it's going to be 1, and altogether it's going to be 160. So the total here is going to be 160. Total here is going to be 160. So here altogether we have 120. 120 plus 40 is going to make it 160. Is that clear? Yes? Okay. Altogether when you add these numbers, you should get how much? 400. So 160 is there, 140 is there. The addition comes to 300. 300 subtracted from 400 will give you how many 40 to 59 age people were called, right? And then now you know here 100. Now you know these two values. What's the value that should come here? Here it's going to be 72, so it's going to be 28. Please check with your answers if you have got the same. So this is how you have to fill it. And again, once again you can check here. Now here when you add how many you are getting? 40 plus 12 plus 28, it's going to be 80. Correct?
Yes.
Here it's going to be 40, 40, it's going to be 80. 80 plus 80 is 160. 160 plus 240 here again adds up to 400. So you can see all numbers tally with the total number. Is it clear?
Yes.
This is how we do this type of question. A bit tricky, but you just have to understand and do a little bit of calculation there. Okay, next question 6. It's a STEM question. The amount of E. coli bacteria found in 200 samples of drinking water is shown in the table here. So here they are showing CFU per 100 ml. This is given here, how much bacteria they have found for each type of 100 ml. So frequencies are given here for each group. Estimate the probability that a sample of drinking water contains less than 100 CFU per 10 ml.
38
How do you do that question? Right, so less than 100. Less than 100, can it include 100? No. So what are the values we are going to take? These two. Right? So what's the total here? 152. This is for part A. 152 upon how many in total? 200 is the total frequency upon 200. So when you simplify, you will get the answer as 0.76 as a decimal. The safe limit for E. coli in drinking water is 200 CFU per 100 ml. Right? 1,000 samples of drinking water were taken. Estimate how many have unsafe levels of E. coli. No, this is how we find the answer. Now the safe water level is 200 CFU. Okay. So then they are asking to find, without saying it straight away, they are asking to find the relative frequency for this and then multiply it by the 1000 samples they are taking, right? Below 200 is safe. So all these are safe, but above 200 it's not safe. So they are asking how many unsafe levels are there. So what are the two unsafe levels here? 39, the last two out of 200. And this is the relative frequency of the unsafe levels of equally. And we have to check this for 1000 samples. So 1000 samples, what's the answer? Yeah, so the answer is going to be 195. 195 samples you are going to find it unsafe. Investigate the meaning of the unit of measurement CFU divided by 100 ml. Anybody has any idea?
No.
So you can write the answer like this. It means colony forming units per 100 ml. This is the answer. Okay, so question 7. A school recorded photocopier use over the autumn term. So in this table they show you which type of photocopies they have taken, black and white, and then have color also. And then there are different sizes, A3 and A4. So this table shows so in this one it shows for each size how many black and whites and how many colors were taken. So the total for all A3 papers are given here. The total for all A4 papers are given here. Altogether, if you take the black and whites for both sizes are given here. Then color printouts taken for both sizes are given here. Total number of photocopies taken including black and white, color, A3 and A4 is this. So this is the total number. Okay, don't mix it up with the other numbers given here. So this is the total including all 4 categories. Is it clear? Right. Now they are asking you, giving you answers to 2 decimal places, estimate the probability of the next copy being black and white and A4. Black and white means this column. A4 means this one. So this is the number you have to find with the total, right? So how do you write the answer for the first one? First one is 13,776 divided by 18,860, which will give you the answer as 0.73. You can use a calculator here if you need. Okay? Right. The next one, they are asking you to find the color. To find the next one being a color printout. So color printouts, they are not telling here which size. So we can take both sizes here. Is it clear? Yes. So we can take both sizes here. So we have the total color printouts taken. Yeah. So what are the values we are going to write here? 4,103 divided by the total number 18,860, which will give you to the nearest 2 decimal places. You can take the answer as 0.22. 0.21. Alright, 21, and there is another part there, so you can round it off to the 2 nearest decimal places, which will be 0.22. Now next part, the autumn term was 16 weeks and the spring term is 12 weeks, right? Now this is for autumn term. Now this is for 16 weeks. all these calculations for 16 weeks. Now they are telling something about a spring term which is 12 weeks. The school needs to order photocopy papers for the spring term. Paper comes in packs of 500 sheets. How many packs does the school need to order of A3 paper and A4 paper? Now how do we find this? This whole thing is for 16 weeks, right? And we need to find for 12 weeks. How do you do the calculation? Any idea? Now here they are telling this whole thing was for 16 weeks.
Yes.
So whatever the number you are taking, you have to divide it by 16 and multiply it by 12 to find for the spring term. Is that part clear?
Yes.
Yes. For A3 papers, see how many A3 papers in total they have taken for autumn term? It's 2705, right? So what are we going to do here? 2705 we are going to divide by 16 weeks. Why? Because 16 weeks were there for autumn term, right? And then we are multiplying this whole thing by 12 to find for the spring term. What is the answer here? (2705) divided by 16 multiplied by 12, it's going to be 2028. 20, let's round it off and take 29. Now I am going to divide this by 500. Why? Because 500 sheets are there in one pack. So I need to find how many packs. These are the number of sheets here. I need to find how many packs they need to order. So I am going to divide it by 500 because in one pack it says there are 500 sheets. Is that clear?
Yes.
Right. Then what is the answer I am going to get? I am going to get 4.06. So 4.06 packs we can't take. So we can say we are rounding it off to 5 packs. 5 packs of A3 paper. The same way for A4 paper, can you all tell me the answer?
No.
A4, how many papers are there? Altogether they have taken 16,155 for the autumn term. So by which number we are going to divide it? By 16. And then we are going to multiply it by 12 to find for the spring term. And then you are going to get an answer there. Let's see what is the answer. Divided by 16 multiplied by 12, it's going to be 12,116, and this answer is given in number of sheets. So I am going to divide it by 500 to find the number of packs I need. So when I divide it, I am going to get the answer 24.23. I cannot buy 24.23 packs, so I am going to round it off for the nearest whole pack. So I need 25 packs of A4 paper. Is this clear?
Yes.
Alright.
Yes.
Okay, shall we move to question 8 then?
Yes.
Yes. The table shows the earnings of a company's employees. Earnings given per annum. Earning is given as E, letter E. Number of employees for each pay group or the earning group is given here. Let's calculate the total frequency here. Total number of employees. How many are there altogether? 5 plus 21 is 26. 26 and 30, 56. 56 and 22 is
83. 81.
81 is the answer. Yes, 81. Right, totally 81. Right, let's just keep that in mind and let's go to the questions now. What is the probability that an employee picked at random earns less than the median earnings? Less than the median earning. What is the median of a set of data? It's the middle value, right? It's the middle value. Less than the median earnings means what are the sets of values we have to take here? Right. So less than the median earnings. Now this is the explanation I have given in detail here. Let's just go through. Probability employee earns less than the median. First you have to find the median position. How do you find the median position? Now here 81. No?
Yes.
So we will add 1 and divide it by 2. Then we are then we are getting the 41st as the median position. Okay?
Yes.
Right. Now if you take the cumulative frequencies 0 to 10, it's 5. Then up to 20, up to 20k, both these added. So it's 26.
Yes.
Is that clear?
Yeah.
Then up to 30k, all three values added together, you get 56. So where does the 41st position is placed? It's in this group, right?
Yes.
It's in this one.
Yeah.
So then the 41st value lies in the 20 to 30k group. This one. Is that clear?
Yes.
So by definition, half the data are below the median. So number below median is 40 employers. And therefore you can write probability equals to 41 upon 80, that is 0.51, and you can write it as a percentage 51%. This is how you calculate that. Is that clear?
Yes.
Right. You can copy it down. Right, for the part 2 they are telling what is the probability that an employee picked at random earns more than the mean. More than the mean. How do you get this value? The estimate for the mean is 24,629.
Yes.
How did you get this value? How do you get this value? Now for each case, what is the middle value? 0 to 10,000 is 5k. Is that clear?
Yes.
Right, here it's 15k.
K.
Here it's 25k.
K.
Here 35k.
5K.
And the next one 45k. Now what am I going to do? Now these are the middle values. No, I am going to multiply this by this. Here what am I going to get? 25k. Right, now I will use the calculator to give the answers. So next one I am going to multiply 15 by 21. What's the answer? I am going to get 315k. Then 25 by 30. What should be the value? 750k. Here what's the value? 35 into 22. 770k. Next one, I'm going to multiply 45 by 3. 135k. I'm going to add them all together. How much will I get? 135, 770, 750, 315, 25k. I'm going to get 1995k. How do I write this answer? 1995, and I'm going to add 3 zeros instead of this. Okay, so I have got 1,995,000.
Yes.
Now to find it for per employee, I'm going to divide it by 81. Okay,
Yes.
so I'm going to divide it by 81 now. Then I am going to get the answer, this one. When I divide this, I am going to get this answer here. That is how I got this answer. Is that clear?
Yes.
Right, so this is a calculation I did. Now, when I round it off to the nearest 1000, I can say this is equal to 25,000. Then I have given an explanation here. It is reasonable to assume that approximately half the people in the 20,000 to 30,000 group earn more than this. So 40 upon 81 is 49% or 50% would be good estimates for the number earning more than the mean. So how you got the calculation is this, and the explanation you can give for this is this. This is for part question A, part 2. Is that clear?
Yes.
So you can take a minute to write down this answer. You can copy it down in your book. I think if you don't have much space there, just see how is it. But anyway, write down how you got it, otherwise you will not understand how you got these values. So for the next part, question in part B, in that it says explain why the probability you calculated in part A2 is an estimate. The mean is estimated. The number for those earning more than the estimated mean is itself an estimate. So you can write down this answer for part B here. Alright.
Yes.
Okay. So that's all for the questions for checkup, strengthen and extend. So if you have any questions or wherever you don't understand, just drop a comment and we will provide the answers or explanations as necessary. And that's it for today. Then see you next time with a new lesson. Thank you.